Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today I am going to discuss the sample paper of NCERT published by NCERT from 2024-2025 sample paper 1. So we will going to discuss all the sample papers as much as possible. So today I am going to discuss sample paper 1 physics part. Obviously I am going to discuss. Let's see the question paper. We have 3 1 marker, I think 4 1 marker question, 2 marker question is 2, 3 marker question is 3, 5 marker question is 1, and 4 marker question is another 1. Total 25. I think assertion and reason are not included, so maybe I think there will be +1. Okay, so that was missed. So +1 here, +1 here, and total we have 26 marks. 26 marks, right? So let's see section A, 1 marker. First of all, 1 marker question MCQs. In the following cases, a ray is incident on a concave mirror. Okay, in which case is the angle of incidence is equal to 0. So angle of incidence is equals to 0 means it is a normal incidence. Okay, for example, suppose this is a plane mirror. In that case, if the ray is falling along the normal, then it is a normal incidence. In that case only we know that angle of incidence is 0. Now in case of a concave mirror or in case of a convex mirror, when the ray is traveling through the center of curvature, okay, does not matter how it is traveling. If it is traveling along the center of curvature, we know that the ray of light comes back along the same path, right? This is one of the tricks that we use while drawing ray diagram. Now why it is so? If the ray of light is passing through the same path, that means angle of incidence must be 0. So that's why angle of refraction is also 0. Reflection is also 0. So that's why it is coming back through the same path. So the ray parallel to the principal axis, this is definitely not passing through center of curvature. A ray passing through the center of curvature and incident obliquely, definitely this is the answer. We know that. Let's check the other options. A ray passing through the principal focus but obliquely, so this is passing through the focus but obliquely does not have any relationship. After passing through the focus it becomes parallel, so obviously incident angle is not 0. A ray obliquely to the principal axis, the pole of the mirror, so this is obliquely to the pole of the mirror. This is also not the case where incident angle is 0. Angle of incidence is not 0 in this case, right? So angle of incidence is 0 only when it is passing through the center of curvature. Now this is question number 14. Choose the correct option for the color of rays A and B. So here we have seen one white light passing through the prism, and one ray is passing through A, one ray is passing through B, and we have to choose the color. Now we know that this will be red and this will be violet, right? VIBGYOR. Right, this is the form. The other rays are not shown obviously, so the extreme rays are shown. So extreme rays means the ray A will be R, red, and ray B will be violet. So let's see the option. So if you see the option C is correct, right? Option C is correct, where color of ray A is red, color of ray B is violet, right? Now next question, assertion reason which question. Okay, so there are 3 questions only, so my mistake. Assertion A, a convex mirror always forms an image behind it and the image formed is virtual. Okay, a convex mirror always, so convex mirror always form the image behind it. So definitely if the object is here, you will get some image here, okay, somewhere here. So this is always behind the mirror and it's always virtual, right? This is a correct statement. Assertion is correct. Reason, according to the sign convention, the focal length of convex mirror is positive. Yes, according to the sign convention, focal length is also positive, but is it correct explanation? Is this statement is correct explanation for the reason? I guess no, right? So this is not the correct explanation for the assertion. So both A and R are true, but R is not the correct explanation of A. Okay. Now let's move on to the next question. Oh, there are 2 assertion and reason questions. So I was correct. Okay. No, this is a different chapter question. This is not for from physics. So let's move on to the section B of 2 marker. Okay, now this is the question. The above figure shows the formation of an image by a lens shown in the thick line. Analyze the figure and answer the following questions. What is the type of the lens used? What is the nature of the image? If the image formed at a distance of 30 cm from the lens, the image twice the size of the object, then where is the object placed? Okay, let's see the answer. The lens is a convex lens. Why it is a convex lens? So if you see, the image is virtual but it is enlarged, right? So image is enlarged and virtual. That is only possible for convex lens. For concave lens, image is virtual but it is smaller than the object and it is generally formed ahead of the object, right? In this case it is behind the object and it is inverted, right? That's why we always say that this is a convex lens, right? And they have reversed the image to confuse you. Okay, so that you get confused. Generally we no, this is also fine. They have removed the lens, right? So this is a convex lens. First part. Second part is image is virtual. As you can see, image is forming behind and you have to extend the lines ray of light to get the object. That means if the ray were actually intersect, if two rays were actually intersect, then you could have said that okay, this is a real image, but they are not getting intersected, so you are tracing them backward to get the image. And also there is another hint, is that the image is drawn with a dotted line. So dotted line means definitely it's a virtual image. Okay, now magnification of the lens is given by 2. Okay, so magnification is given by V by U, that is equals to 2. Okay, or we know that magnification is basically V by U. So you are asked to find the U. So V is minus 30 centimeter, twice of the size. So minus 30 centimeter on the same side of the object. So minus 30 centimeter, that is equals to U. There is a mistake here. There will be no U here. Okay, there will be no U here. So minus 30 centimeter divided by U, or U is equal to 30 by 2, that is 15 centimeter. Right? Got it? Any doubt? If you have, don't forget to mention that in the comment below. Now visually impaired students, now these questions may seem that not relevant, but these visually impaired students, they are also very good question and they might come as a standalone question to you as well. Okay, maybe you ignored these questions because they are for visually impaired and you are saying that I am not visually impaired, I can see perfectly fine, so this question is not for me. Actually not. Okay, they are very very good questions. So you have to, when you are solving sample paper, you have to solve everything including visually impaired. What type of lens always form a virtual, erect and diminished image? Okay, always forms virtual, diminished and virtual, erect and diminished image. Think the answer in your mind. I will answer in a while. List 2 uses of such lens. So if it is always forming virtual image, what is the use of that? Okay, and it's a lens, okay, not mirror. So be careful. So let's see the answer. The answer is a concave lens. Concave lens always produces virtual and erect and diminished image. Okay, correction of myopia and peepholes of doors of any other correct alternative. Right? So basically those who are suffering from myopia, for example like me, I am suffering from myopia, I have to use a concave lens to correct my vision. Similarly the peepholes where you see through the door, okay, that's where someone is outside, so that peephole is also used a concave lens, so that it's a virtual image, it's a small image. Okay, there are a lot of combination of lenses where concave lenses are used. So these are the 2 common examples that is given to you. Now next, 25A, the electric circuit given in the figure in closed dia contains 2 heaters. So this is basically a closed dia system and they have 2 electric heater, okay, X and Y in parallel. The above figure shows the circuit connected to a 230 volt power supply. When both switches are closed, the current in the circuit is current in X is 3.5 ampere. So current in X is given, it is 3.5 5 ampere. Okay, analyze the circuit given above and answer the following question. Calculate the power developed in the heater. So what is the formula for power developed in the heater X? So power developed, the formula is, I am giving you Vodafone Idea, VI, right? If the resistance of X is double that of Y, so if the resistance of X is double that of Y, so if the resistance of Y say R, then X is double of that, that is 2R. Okay, calculate the current in the heater Y. So you have to calculate the current in the heater Y. Now let's see the formula. First problem is P is equal to VI. So I said V is given 230 volt. Current is also given 3.5 ampere. So power is 805 watt. Now we know that current, relationship between current and resistance is that V is equal to IR. That means I equals to V by R. So there are two ways to solve it. Okay, you can calculate the resistance of R and then half it, calculate the current for other one. But the most important thing is that I is proportional to 1 by R. Right, I is proportional to 1 by R because voltage is constant. So more the resistance, less is the current. So in this case it is mentioned that R is twice in case of X than Y. Now here we have also given 3.5 ampere. So if 2R gives me 3.5 ampere, then single R should give me twice of that current, that is 3.5 into 2. Right, so current, because current is inversely proportional to the resistance. Okay, and the current in this case is given already 3.5, so current in this case will be 3.5 into 2, that is 7 ampere. Okay, you can solve it simply like that. Okay, so if it is R by 2, then you have to multiply with 2 in the upper case, right? Similarly here 2R, so 2 you have to be multiplied here, right? Now next question, the above figure shows, this is a part B question, shows two resistors X and Y connected in series in a battery. The power dissipated for this combination is P1. Okay, when these two resistors are connected in parallel to the same battery, then the power dissipated is given by P2. Find P1 by P2. So this is the resistances. One resistance is R, another is 2R, and in this combination power dissipated is P1. Now if you combine them in parallel, the power dissipated is P2. You have to find the ratio of P1 and P2. So very simple. First we have to find the power dissipated in the first case. What is the formula for power dissipation? Yes, P is equal to VI. I always say that, but there is another formula. P is equal to VI, but I is not known in this case. I cannot be calculated directly. So what we will do? We will put I is equal to V by R. That is P is equal to V square by R. This formula we are going to use. Okay, so P1 equals to V square by 3R. Why 3R? So here R and 2R are in series connection. So in series connection, the equivalent focal length is addition of these two, right? So that is 3R. Right, now for parallel connection, the total resistance for parallel connection, when they are connected in parallel, okay, the equivalent resistance is given by R into 2R divided by R plus 2R. You remember R1 R2 divided by R1 plus R2. So two resistances in parallel, this is the shortcut formula. So this is the formula, so you have to apply this. So this will be 2R square divided by 3R. So one of the R will cancel, you will get 2R by 3. So this is the parallel combination resistance, 2R by 3. So P2 is, again we will use the same formula, and in this case you will use V square by 2R by 3. So you will get 3V square by 2R. Now if you divide these two terms, V square by 3R divided by 3V square by 2R. Okay, so what will be the value? V square by 3R into 2R divided by 3V square, right? It is like a division, so it will reverse. So v square cancels, r cancels, so you get 2 by 9. So 2 by 9 is the answer in this case. Now let's move on to the next question. For visually impaired, again I always say do not ignore this question. We have 4 resistors A, B and C and D of resistance 3 ohm, 6 ohm, 9 ohm and 12 ohm respectively. Okay. Find out the lowest resistance which can be obtained by combining these 4 resistors. So you have to remember that to get the lowest resistance possible from a combination of resistances, they are always have to be connected in parallel combination. Only parallel combination gives the lowest possible resistance, whereas to get the maximum resistance you have to apply series combination. And if you apply any other combination of mixture of, suppose 2 is in series, 2 is in parallel, then the resistance will be intermediate. For maximum resistance, they has to be connected in series. For minimum resistance, they has to be connected in parallel. What else? You are given 2 fuse wires A and B with current ratings 2 ampere and 5 ampere respectively. Justify with reason which of the two would you see with a 100 watt, 1000 watt, 220 volt room heater. So we will see the answer in a while. So first of all, as I said, resistance will be lowest minimum if all resistors are connected in parallel. The equivalent resistance for parallel combination is given by, now here we have 4 resistances, so you cannot use shortcut method, you have to use the regular method. So 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So after doing the LCM, finding the R equivalent, don't forget to take the inverse after you calculate this, because inverse is very important. Here it is 1 by R equivalent. So at the last stage you have to take the inverse to calculate the final value, that is 1.5 ohm. Okay. Now, so power rating of the fuses are given as current rating is 2 ampere and 5 ampere, whereas power and voltage are given. Okay, power and voltage were given, so we have to find the current. So we know that power is equal to VI, so current is basically power by voltage, and it will come out to be 4.54. So 4.54 means the fuse that we want to use will be very close to that rating, that current rating, that is in this case it must be 5 ampere. If you use 2 ampere one, then what will happen? This is because it will be able to sustain the current 4.5 ampere passing through it, whereas a fuse A will melt and break circuit as its current exceeds its rating. Current A is only 2 ampere rating, and current B and fuse B is 5 ampere rating. So definitely you have to use fuse B. Okay, if you use fuse A, then it will burn and melt, it will break the circuit, right? So this is how you have to think. Now next question, section C, 3 marker question. Let's see, what is the fundamental difference between hypermetropia and myopia in terms of the optical experience of a person? Okay, the diagram below shows a special case of an eye defect. What is the defect that is shown in the figure? State the cause of the such defect. Explain with reasons if a concave lens can be used to correct this defect. Okay, so let's see. Hypermetropia is a defect that causes difficulty in focusing near objects. So basically you cannot see nearby objects. Okay, with this is called farsightedness. Far you can see clearly, that's why it is called farsightedness. Okay, with clear vision observed for distant objects. So hypermetropia means you cannot see close objects clearly, but you can see distant objects clearly. In myopia, distant objects appear blurry while near objects are seen clearly. Okay, so distant objects appear blurry whereas near objects can be seen clearly. That is myopia, myopic eye. Okay, the image shows in case of hypermetropia. If you see this image, so in this case, as you can see, the near point has shifted, and that is why the near point has shifted beyond the retina. So this is a hypermetropia. If the rays were parallel like this, then it was a myopia. And if they are focusing somewhere in the front of the lens, we say this is myopia. But here it is starting somewhere finite distance and it is going beyond. That means it is a hypermetropia. shortening of the eyeball or the focal length of the eye lens becomes too long. So this is the two reasons. Okay, not concave lens, no, the concave lens would diverge the rays coming towards the eyeball and will push the image even further, but convex lens should be used to help the converge the rays and create the image in the exact place on the retina. So hypermetropia can only be corrected by convex lens, not concave lens. Okay, concave lens, it will make more diverge, it will go further beyond, so whatever you are watching, it will become more blurry, right? But in case of convex lens, it will make it appear clearer. Now for visually impaired student, what is the fundamental difference between hypermetropia and myopia in terms of optical experience of a person? Obviously same question. What are the causes of myopia in the human eye? So first part is obviously same. Myopia, distant object, nearby object bloody. High converging power of eye lens, elongation of the eyeball. So if your eyeball is elongated or your eye lens is having high power, then your rays coming from a distant object, they focus much before they reach the retina. So that is one of the reason how your myopia can be developed. Right, now next question, state the relationship between resistance R of a wire to its length L, cross-sectional area A. Use the mathematical symbols to arrive at the final formula. Using the formula, define the resistivity of a material. Let's see. So R is proportional to L, R is proportional to L by A. So if you first you have to write one more thing. Resistance is proportional to length, directly proportional to length. Resistance is inversely proportional to area. So combining this, we can write resistance is proportional to L by A. Now if I want to remove this symbol of proportionality, then what I have to do? I have to add a constant. That constant is called resistivity rho. So R is equal to rho L by A. Now so we can write R is equal to rho L by A, or rho is equal to R A by L. Now if I make A is equal to 1 meter square, L is equal to 1 meter, then rho will become R, right? So if A is equal to 1 meter square and L is equal to 1 meter, we have rho is equal to R. Hence, the resistivity of resistance offered by a wire of length 1 meter having a cross-sectional area of 1 meter square. So, that is the resistivity. Resistivity is the resistance offered by a wire of length 1 meter and cross-sectional area 1 meter square. Now, Mona was doing an experiment with a magnetic compass and a straight current carrying wire. She observed that as she moved the compass away from the current carrying wire, the deflection of the compass needle reduced. Okay, so basically she was doing some experiment. As she moved the compass away from the needle, away from the conductor, the deflection which was there, it was more. Now slowly it reduced. Okay, explain why the deflection of the compass needle reduced as Mona moved away the compass needle from the current carrying wire. Mention one thing that could have changed in the circuit of the wire that could have increased the deflection of the needle. Okay, so there are two questions. Explain with reason what will be the direction of the magnetic field associated with the wire for the case described by the above figure. Okay, so there is a figure also. Unfortunately, the figure is not showing here. Magnetic field strength is inversely proportional to the distance from the current carrying wire. Hence, the Mona moved the compass away from the current carrying wire. The magnetic effect was less, and it hence deflection was less. So, as I mentioned, if you have watched my classes, that when you are moving away from the conducting wire, the magnetic field strength decreases because it is inversely proportional to the distance. So as you are moving away, it field strength decreases and the deflection decreases. Magnetic field strength is directly proportional to the current in the wire. So Mona could increase the current in the circuit to observe the greater deflection in the compass needle. So if you increase the current in the circuit, increasing current means magnetic field will increase. More magnetic field means more deflection. The battery suggests that the current is going from the top plane of the bottom, so this part is missing. Anyway, I am not going to discuss this. You can check the sample question paper and tell me the answer. Now for visually impaired student, explain why the deflection of the compass needle reduced as Mona moved away from the compass. This part is same. Mention one thing that could have changed. So this is also same. Explain with reason how the direction of the magnetic field associated with the wire changes if the polarity of the battery reverses. So you have a current carrying wire. Okay, you have a current carrying wire, and what will happen if you change the polarity to the magnetic field? How the magnetic field will change if you change the polarity? So basically, what is the meaning of that? You change the batteries, so plus is now minus, minus is now plus. What will happen? So this is suppose north pole, orientation was north south. Now what will happen to the north south direction if you just change the battery? So when the polarity of the battery is reversed, the direction of the current flowing in the wire and the direction of magnetic field will also be reversed. So magnetic field will reverse. So magnetic field reverse means now initially this was the north pole, this is the south pole. Now it will also reverse. So it will be go some way that not some way, it will just exactly opposite. So now this will be south pole, this will be north pole. Okay, this is not that simple. It will not exactly happen like this because Earth's magnetic field is also present, but in absence of Earth's magnetic field, it will simply reverse the opposite side. Okay, now 5-marker question. This is a very interesting question. The above circuit is part of an electric device. Use the information given in the question to calculate the following. Potential difference across R2, which is R2. R2 is this one. This little one is R2. Okay. Value of resistance of R2. Potential difference means what is the voltage difference between these two. What is the value of R2? Value of resistance R1. So what is the value of resistance R1? Let's see. So potential difference across 4 ohm resistor is equals to potential difference. So potential difference across this same is this, right? So whatever potential difference across these two resistors, this is same because they are connected in parallel combination. So this combination, this resistance and this resistance, they are connected in parallel combination. Now what is the potential difference across this resistor? Resistance is 4, current is 1.5. So voltage drop is basically multiplication of these two. V is equal to IR. So V is equal to IR. If you solve it, you will get that this is basically 6 volt. The same resistance, same is across R2. So VR2 will also be the same value, 6 volt. Now total current through 4 ohm and R2 is 2 ampere. It is given. Let's see. So total current in the circuit is 2 ampere. Okay, and total voltage is 12 volt. Okay, total current through 4 ohm and R2 is 2 ampere given. Current through 4 ohm is 1.5. So current through R2 will definitely be the difference in that. So current that coming here is 2 ampere and 1.5 is going through this. So the remaining current will pass through this. So this will definitely be 0.5. Right? So 1.5 is passing through this. So 0.5 will pass through this. Right? Next question. Using Ohm's law for R2, we get that 6 volt is the voltage, current is 0.5. So R2 will be 6 by 0.5, that is 12 ohm. So we have calculated the resistance as well. Now potential difference across R1 is equal to total potential difference minus potential difference across R2 minus potential difference across 2 ohm. So what is the meaning of that? So here we are trying to find the value of resistance R1. So how to do that? The voltage drop across this resistance, this must be total voltage, that is 12, minus voltage drop across this piece of set, that is 6 volt, and voltage drop across this resistance, right? So minus 2 into 2. right? So 12 minus 6 minus 4, that is 12 minus 10, that is 2 volt. Okay, easy. Slightly if you have knack of solving some numerical, then only you can solve this question. Okay, so this is 2 volt and current through R1 is 2 ampere using that is already given. Current through R1 is given. If you see 2 ampere is given, so using Ohm's law, R1 is equal to 2V by 2A, that is 1 ohm. So R1 is 1 ohm. You have to practice this kind of numericals more often to have a grasp on that. Now next question. As shown in the figure above, A and B are two lamps. Okay, lamp A is rated 12 volt 24 watt, lamp B is rated 6 volt. When the lamp B operates in its rated voltage, the current is 3 ampere. The value of R1 and R2 are chosen so that both lamps operate at their rated voltages. Based on the information given, answer the following. So lamp A is rated as 12 volt, lamp B is rated as 6 volt, 12 volt 24 watt. Okay, and lamp B is rated as 6 volt. When the lamp B operates in its rated voltage, the current in it is 3 ampere. So lamp B, when it is operated current voltage, the current is 3 ampere. The wattage rating of the lamp B is not given. Okay. Now R1 and R2 are chosen such that both lamps work at their rated voltage. Okay, calculate the current in lamp A. So you have to calculate the current in lamp A, then state the give reason for the reading of the voltmeter. What is the reading of the voltmeter? Why the voltmeter will show some value? Okay, calculate the resistance of R2. So resistance also you have to calculate. Next what? Find the value of resistance R1. So R1 will also have to calculate. Let's see. So use P is equal to VI. Power is equal to Vodafone Idea. Power top up. Right? So in the first case, that is here it is given that voltage is 12, power is 24. So you can simply calculate P is equal to VI. So P is given, V is given, you just need to calculate I, right? So current will be equals to 2 ampere, right? Now voltmeter reading is 12 volt in the lamp A. Voltmeter reading is 12 volt. Lamp A and lamp B are in parallel, hence potential difference across arm containing A equals to potential difference across arm containing B equals to 12 volt. So because those two lamps are connected in parallel, okay, here there is a lamp, here there is a ramp as well as some resistance. So both will have the, because they are connected in parallel, both of them will have the same voltage. Okay, that is the beauty of parallel combination. Okay, so both voltage drop across the lamp 2 will also be 12 volt. Potential drop across R2 plus potential across lamp B should be equals to 12 volt, right? Hence potential drop across R2 is 12 minus 6 volt. Why? Because the rating of this lamp is given 6 volt. Now we have already calculated the voltage drop across this is 12 volt. So total is 12. Okay, now from this, if we can deduct this 6 volt, the remaining 6 will be across this, right? So it has to be match, it has to match, right? Total voltage is 12 volt. So 12 volt, this already consuming 6 volt. So the other one will also consume 12 minus 6, that is 6 volt. Okay, now current through R2 equals to current through B, that is 3 ampere. It is also given. So from there you can calculate the resistance of R2, that is 2 ohm. You have to solve this question on your own. Next is current through R1 is equals to total current, that is equals to 5 ampere. So potential drop across R1 is 15 volt minus 12 volt equals to 3 volt. So this is also give you 0.5 marks, and R1 is equal to 3 volt minus 5 ampere, that is 0.6 ohm. So this is also give you 0.5 marks. So total marks you will get 5 marks from this question. Now there is a question for visually impaired. Now this is a difficult question. Different question. Okay, state the law and write the formula connecting electric current flowing through a conductor and voltage applied across it, that is Joule's law of heating. In household, five fans each of 100 watt are used for 4 hours and an electric press of 5 watt for 2 hours every day. Calculate the cost of using the fan and electric press for 60 days if the cost of 1 unit for electrical energy is 6.5 rupees. Now there is our question, state Joule's law of heating and write its mathematical expression. So in this case they ask you P is equal to VI, in this case they have asked you H is equal to VIT or H is equal to I square RT, everything is same. Two resistors of resistance 2 ohm and 4 ohm are connected in series and parallel with a battery of given potential difference. Compute the ratio of total quantity of heat produced in the combination in two cases if the total voltage and the time are kept at same for both. Let's see the question. First, okay, sorry, my mistake. So first question was state the law of right formula connecting electric current flowing through a conductor and voltage applied across. My mistake, I understood it is about the power, but actually not, it is about V and I. So V and I is basically linked with Ohm's law. So Ohm's law is the first question. Ohm's law is the law which states that the electric current I flowing through a conductor is directly proportional to the voltage applied across it and inversely proportional to the resistance of the conductor. Mathematically it can be represented as V is equal V proportional to I or V is equal to IR. Okay. Now let the energy consumed by the fans be EF and the energy consumed by the electric press is EP. So total power is equal to P into T. So you have to calculate the total power by fan. Okay, similarly you have to calculate the total power by the electric press, right? So kilowatt hour, how many hours it is working, what is the watt rating. So how to calculate that watt rating? Suppose it says 500 watt, operates for 2 hours. Okay, so this will give you the watt hour. Now if you divide everything with 1000, then you will get the kilowatt hour. That is what they have done. So this is watt, this is hour, and this is just divided by 1000 to get it in kilowatt hour. So 502 divided by 1000, that is 1 kilowatt hour by the electric press. So total energy consumed in 1 day is 1.4 kilowatt hour. So total energy consumed in 60 days, 2 months, right? That will be 84 kilowatt hour. So the total cost is 84 into 6.5, that is 546 rupees. Okay. Now, Joule's law of heating states that the amount of heat produced in a conductor is directly proportional to the square of the electric current passing through it. The resistance of the conductor and the time for which the current flows, mathematically represented by H equals to I square RT. H is the heat produced, I is the electric current, R is the resistance of the conductor, T is the time for which the current flows. Now, next question is 2 and 4 are connected in series. The series resistance is 6 ohm, and if they are connected in parallel, the parallel resistance is 4 by 3. Now, first case, the heat produced is V square T by R. In the second case, it is V square T by R again. So basically, the ratio is the ratio of resistances in the inverse order. It will be again 2 by 9. Now, we have already used 2 by 9 once in one more problem. So this is also 2 by 9. Now section E, 4 marker, that is case based question. So here a beautiful picture is given. The above image is that of a reflecting telescope. Reflecting telescopes revolutionized our ways of looking into the sky. They employ mirrors to gather and focus light rather than relying solely on the lenses as in their refracting counterparts. These telescopes utilize precisely shaped and polished mirrors to capture incoming light and reflect it to a focal point where it forms an image for observation. What kind of image of the star is seen in the observer at the eyepiece? What kind of mirror is used in this reflecting telescope? So let's see what is the image formed by this eyepiece and what is the type of image formed by the mirror. Okay, there is a subpart as well. Attempt either subpart C or D. Explain with reason what kind of optical device, type of lens or mirror that is used in that eyepiece. So you have to identify the eyepiece here, obviously clearly visible, right? And secondly, what is the role of the plane mirror in the telescope? What is the role of this plane mirror in this telescope? Okay. Now, real image, the final image is formed to the lens at the eyepiece. So basically it's a real image, right? The mirror that is used in the first case is definitely a concave mirror, right? We can see that this is a concave mirror, and the name of this type of telescope is called Cassegrainian telescope. Okay, student, to attempt other subpart C or D, the converging lens used at the eyepiece to collect the rays from the plane mirror and help the viewer to see the real erect image of the star. So basically eyepiece is the one which collects the rays that is coming from the mirror and collects it, and the observer can see through this eyepiece. The plane mirror literally inverts the image formed by the curved mirror, and its position helps to detect the rays towards the eyepiece. So the plane mirror does two things. It inverts the rays, it changes the direction of the ray after reflection, so that you get a clear image on your eyepiece. Okay, because you cannot so if there was no mirror here, okay, what would happen? The ray would have formed here, and how would have you observe it here? That is very, very difficult, right? But this plane mirror helps the reflect the light, change the direction of light, and through here you can see what is the ray that you are getting it, right? So that is why it is used. Now let's see, for visual impaired students, Azim Tarapurwala was a traveler and science enthusiast. During one of his travels, he found himself on the edge of an island without any mode of communication. As he had read many stories, he thought he would light a fire on the beach, and traveling boats or ships would see that fire and come to give him a ride. He had run out of lighters and matchsticks, but he had a reading glass. Being a science enthusiast, he knew some tricks and used that lens to scrap a paper to light a fire. With the help of scorching rays from the sun, okay, which lens can be used by Azim to create the fire? What property of the lens helps Azim to create the fire? Very interesting question. Actually, this is the easier question, right? This is a case-based question, and previous one was also case-based question, but this is slightly easier. Attempt either subpart C or D. List two more uses of this kind of lens. Explain with reason the condition under which the lens can be formed both real and as well as virtual images. So let's see the answer. Convex lens, obviously convex lens, we know that if you use a convex lens, okay, it can focus parallel rays from the sun. They can be focused at a single point, and we get burning here, right? Converging property, the lens can converge parallel rays into one point. Okay, to correct the hypermetropia, so if you are suffering from hypermetropia, then convex lens is used. Okay, lenses of telescope, microscopes and side projectors, okay, so they are all used convex lenses. Also the eyepiece of a microscope, they also use convex lens. Okay, if the object is kept between optical center and the focus of the image, obtained is virtual, rest all cases image is real. So if the convex lens is like this and the object is placed between focal length and the optical center of the lens, then we get a virtual image. For all other positions, we get a real image. Okay, very simple, precise and concise answer, right? So I hope you enjoyed this session today. I'll be back with sample paper 2 in coming days. Till then, bye.